Let's explore linked lists and data structures. In a linked list, each node contains data and a pointer. Nodes are represented as boxes or circles. Each node has two parts, data and pointer. The pointer references the next node in the list. Watch how nodes connect with arrows pointing next. Linked lists allow for efficient data management.
At first, the singly linked list is empty, so head is null. Each car is a node. Every node has two parts, data and a next pointer. If there is no car after it, the next pointer is null. Now let's insert a new car at the front. A new car comes in with some data. Here, the new car has number 5. To insert at front, we link the new car to the old first car. Then head moves to the new car. Now, let's insert a new car at the end of the parking lane. The user enters the value, which becomes the data of the new node. A new node is created. In the parking example, this node is represented by a car. The car's data is set, and since it will be the last car, its next pointer is null. We start with a temporary pointer called temp. Temp begins at the head, which means it points to the first car.
To insert at the end, we move from one car to the next until we reach the last parked car. In this case, the car with number 10 is the last car since its next pointer is null. Once the last car is found, we attach the new car to it by updating the next pointer. Now insertion at end is complete. The new car becomes the last car in the parking lane. Now let's look at deletion from the front. This means the first car in the parking lane leaves.
To delete the front node, we store the first car temporarily, shift head to the next car, and remove the first car from memory. This makes car 10 the new beginning. Next, we delete the car from the end of the parking lane. If there is only one car, deleting the end is simple. But here we have more, so we must move forward. We move through the cars until we reach the last one. The previous pointer always stays one car behind the current pointer.
To delete the last car, we set the second last car's next pointer to null and remove the last car. Now deletion from end is completed, and we are left with one car in the lane. These are the 4 key operations in a singly linked list represented with a parking lot example. This completes the explanation of singly linked list operations.